Okay, it's an optional question. It says for x in the real number system, it says find the domain where the solutions would exist. And that's kind of a difficult question because you're looking at it, you wouldn't even know where to start. It goes on to say use a cache to find all solutions to the problem now. All right, so I suspect there's going to be solutions to the problem, and we'll be able to at least know where they are before we look for them. All right, way to do that, I would recommend, is to isolate the sine function first. And this is sine of x plus 8 over x squared. And that's going to equal to that polynomial, which looks like 2 minus x squared. All right. Now, if I were doing this over here, I start to realize that on the left side, I got a sine function, and it's going to look pretty bizarre. And on the right side, you get a polynomial. Now, certainly, just thinking about it graphically, I want to point this out to you, that the polynomial is just a parabola. It looks like this over here. All right. And then the sine function, whatever it looks like, it bounces back and forth between plus and minus 1. So it goes back and forth between, y equals 1 and y equals minus 1. And this is where the solutions are going to be. All right, now what do I know that? It's where the sine function and that parabola would intersect. So what I got to do first is I got to determine where that parabola, right, is between 1 and minus 1. Let me write that down for you. So where does this parabola, where is it going to be between minus 1 and 1? All right? So looking at that, I would say it's a compound inequality, and I would divide it into two parts. So the first part I divide minus 1, 2 minus x squared. And the other thing is an and. It's important you know it's an and. 2 minus x squared. And you learn this in Math 119. So I would, basically solve for 0, which is quadratic, so you would do that. This would be 3 minus x squared. And this one, again, is an and. This one would be, let's see, 1 minus x squared. Well, what I do is put a number line down. And this one's going to be between, looks like minus root 3 and root 3. Certainly it's satisfied at minus root 3 and root 3. If I put 0 there, it would certainly be better than, because 3 minus 0 is certainly better than 0, so it's positive. If you go beyond root 3, like you go, 5, plug it in, it'd be negative, and you put minus 5 in, it'd be negative. So that's solution to that side. And if you do the other guy, let's put this one down over here. That's going to be plus or minus 1 now. That's the roots of it. Certainly satisfied at minus 1 and satisfied at 1. And then if you took 0, unfortunately, if you took 0, 1 would not be less than or equal to 0, so I can't shade that in. But if number like 2, this would be shaded because it would be negative there. And if you put minus 2, it would be negative over there. And again, this is basically Math 119. So this is the Math 119 part. All right? I got to find out where they intersect. So what I'm going to do is I'll put the number lines down next to each other. And let's put down one at a time, root 3. And that's minus root 3, I'm sorry about that, root 3. And that looks like this. Whoops, made a mistake. Let me get my eraser out. Spoke too quickly. Let me just draw it over here. And you get minus root 3, root 3. I'm going to shade it in between. And I'll put the other one down next to it, right on top of it, because I want to find out where they intersect. That's what the word and means. Where do they intersect? And minus 1 would be about here. And plus 1 would be about here. I'm going to say it goes like this and goes like this. So where do they intersect? Let's write this down. It looks like from minus root 3 up to 1, union 1 to root 3. So these are the x's where the solutions would exist. So I have solutions over here, solutions. The question is, I don't know what the solutions are, though. Now, what I mean by that, there's going to be, if I look at the sine function is going to be oscillating over here somewhere. So I just don't know how many times it hits it. So what I would recommend to do is you start to realize that you're probably going to need to use a graph to do it. All right? All right, I put a graph down. But again, we know the solution set is going to be on this interval over here, between minus root 3. You know what? I made a mistake there. I just noticed it. That's a minus 1 here, and I'm sorry about that. All right, so I'm looking at my K. So let's take a look at the picture. And, the picture, I'll go over here, and I'll point out what these lines are, and one at a time. This is the line y equals 1. This is the line y equals minus 1. This is the line x equals root 3. This is the line x equals 1. This is the line x equals minus 1, and this is the line x equals minus root 3. All right? And what I do is I graphed out, a bunch of different things over here. Certainly I see the parabola. That's the blue curve. This is the parabola, and that's y equals 2 minus x squared. And, I'm going to say I can graph all those guys out. What I have a tough time graphing, though, to be honest with you, is this thing over here. And that's the sine function. And if you notice it, it's really oscillating wildly near the origin. But once you go between those limits over here, these limits over here, if I look at the curve, what do I notice over here? There's only one point of intersection over here. And where is that? That's right over here. All right? So somewhere over there about. I know there's one there. So there's one negative one. Let's go to the other side. And then again, the sine curve's oscillating. But what I'm noticing about this guy over here, and I'm noticing there's 3 points of intersection. One's here, and one's there. Right now, there's no way I'm going to be able to solve this using techniques that I'm aware of. So I would have to use a numerical technique. Now, when you take calculus, there's a lot of numerical techniques. But right now, the only numerical technique I have now is to use computer software. All right? So I'm going to say, looking at this over here, I'm going to start making guesses at it. So I'm going to say over here, this solution over here is going to be between, I'm going to say, play it safe, between, I don't know, looking at it, let's take a look. I'd say between -2, play it safe, right, and -1, all right? So I know the solution over here is certainly on the interval between -2 and 1. And there's only one, so that's all I have to worry about. It's where the blue curve hits the green curve. Let me get my eraser out to make sure you're aware of that. Again, the point of intersection is over here somewhere. And I'm going to say it's somewhere between -2 and -1. But there's only one. There's only one place where they intersect. Over on the other side, the positive side, it's much more difficult. All right? And the reason for that, there's 3 of them. And you have to play it safe. I'm going to say this first one over here, right? The first solution I'm seeing over here. Now, again, let me get my eraser out and emphasize what we're talking about over here. I'm looking at this over here, and there's a point there that intersects, a point here, and a point here. Let's just do one at a time. Let's do this one first. I'm going to say, what's safe there? And there's 3 of them, so I get it really kind of divide up. I'm going to say it looks like -1, and then maybe -1.1, all right? If I look at this one over here, I might say this is between -1.1 and -1. Well, let's play it safe, -1.3. All right? This one over here, I don't know. I'm going to say -1.3 and 2. I'm sorry. I'm putting minus sign down there. It's crazy. Sorry about that. I got to correct that. That is not true. Talking about the x's now. So the x's over here, I'm going to say between 1.0 and 1.1. This over here, I'm going to say, between 1.1 and 1.3. And this one over here, I'll say it's between, let's see, 1.3 and 2.0. And I'm going to use software to do that. So let me go to this software and talk you through this over here. I'm using Sage. And the first thing I do with Sage is I reset it. That clears out any kind of problems I might have left over from another session. I define a variable, and then I define the left-hand side to be f of x, and that's sine of x plus 8 over x squared. Let me point out what I mean by that. It's this thing over here. And maybe I should put it over here, this thing over here. And then I made f of x this thing, g of x that thing over there. So I got this over here. And then I got a command in Sage that allows me to find a root. And what the root is really finding a solution to this equation over here. But I have to tell it where it is. And I said it's between -1 and -2. All right? So it looked between that. And what it does, it assigns it to this number over here, x1. Let me go through that. I display it. And it turned out that it gave me this pretty precise number, by the way, as a solution to the problem there. And then I want x2, and I want between 1 and 1.1. Let me point out what I mean by that. We're looking for this one over here now. And, I said find root. What does it do? It finds the root, and it said the root was this thing over here. It's really close to 1, isn't it? And then x3, I said it was between 1.1 and 1.3. Yep, right over here. And I got x3, and x3 turned out to be this number over here. And then x4, I said it was between 1.3 and 2.0. That's right over here. And let's go for that. And we got, that's x4, right? And x4 is this thing over here. So these are the four solutions over here. Solution number 1, number 2, number 3, number 4. There's one negative and there's 3 positive solutions. Again, what I like to do is I like to see how good is it. You know, how much are these functions really agreeing? So what I do is I actually evaluate G at each of these values. For example, at x1, and I evaluate f at x1, and I subtract them. Now, by the way, if it's true, this would turn out to be 0, but these are approximate solutions, so I'm not expecting that. What am I expecting? Something really close to 0. I want to point out, I did it for each of those, x1, x2, x3, x4, and what I notice is I got incredibly small numbers over here. If you look at this over here, sorry about that, these numbers over here are essentially 0. That's, 10 to the minus 13, 10 to the minus 13. It's a really very precise ability to do these computations. Right now, when you take calculus, you'll learn other techniques to find solutions, but the bottom line is the algorithms being used here are really good, right? They're really good. Are they getting exact values? No. If they were exact, I'd get zeros. I'm not getting 0, getting something really close to it. That's about it. Thank you.